Hello. Today we are going to be talking about angles of rotation. So how to graph angles in degrees, radians, and find reference angles and coterminal angles. So agenda for class today, you're going to start by watching this video. Once you are done watching this video, if you are not already in groups, I would like you to move your desks into groups. Of course, wait till everyone in your group is finished. And then as a group, I would like you to work on the in-class note packet for today, which is Unit 5, Notes number 2. And then once you're done with the notes, go on to our Google Drive, make sure that you did all the examples correctly, and then you have the rest of the period to work on your homework. So our objective for today, by the end of class, you should be able to graph an angle in radians and degrees, and then find a positive and negative coterminal angle, as well as, I forgot to write it there, but find reference angles. So go ahead, get out your notebooks, and let's take some notes. So this is Unit 5, Notes number 2, which is all about angles of rotation. All right, so an angle, I can spell, an angle is in standard form, also known as standard position, if its vertex is at the origin and its initial side lies on the positive x-axis. So if we draw a picture of our x and y axis, an angle is in standard position when its vertex is at the origin and its initial side is the positive x-axis. So that would be an angle graphed in standard position. The measure of an angle is positive if the rotation of its terminal side is counterclockwise and negative if clockwise. So if we go back to the drawing of our angle, the initial side is the side where your angle starts. The terminal side is the side where your angle ends. So if this angle were to be made by rotating counterclockwise, it would be a positive angle. But we could have also made that angle by rotating counterclockwise, and that would then be a negative angle. Coterminal angles are angles whose terminal sides coincide. So for example, the angle, actually let me do that in a different color. (30°) is a coterminal angle with, so that's 30°, is a coterminal angle with, so for example, 390° would be a coterminal angle because it has the same initial side and the same terminal side, but we make one more rotation around the circle. So the easy way to find coterminal angles, if we're in degrees, is just to add and subtract 360°, because I want to be in the same exact position. So to find another angle that's the same exact position, you just got to go around the circle again. So there are actually infinitely many coterminal angles because you can go around the circle an infinite number of times. And then, of course, if we're in radians, you can find coterminal angles by adding and subtracting 2 pi. A reference angle is formed between the terminal side of your angle and the x-axis. Does not have to be the positive x-axis, but it needs to be the x-axis. A reference angle is always between, if you're in degrees, 0 and 90 degrees. If you are in radians, 0 and pi over 2 radians, which again, 90 degrees is pi over 2 radians. So reference angles are always acute and reference angles are always positive. So let's do a few examples. Let's graph in standard position find one positive and one negative coterminal angle, and identify the reference angle. So let's look at 285 degrees. So let's get our axes. So 285 degrees. We have our initial side, the positive x-axis, and if this is my circle, I'm going to start at 0 degrees. This would be 90 degrees, 180 degrees, 270 degrees, and then back to 360 degrees, etc. We can keep spinning, but we'll be okay with that. So 285 degrees, since it's a positive angle, our angle of rotation will be counterclockwise. 90, 180, 270, and there's my angle at 285 degrees. Initial side is labeled, terminal side is labeled, and the direction of our rotation is labeled. So check, we've graphed in standard position. So now let's find one positive coterminal angle and one negative coterminal angle. So to find one positive coterminal angle, all I have to do is add 360 degrees. So 285 degrees plus 360 degrees. I might have just said 180. If I did, that was a complete mistake. It should have been 360. So 285 plus 360 degrees gives us 645 degrees. To find, so that would be this angle here, going around 360 degrees and then spinning to 185 more, so a total of 645 degrees. To find my negative coterminal angle, I take 285 degrees, subtract 360 degrees, so my negative coterminal angle is negative 75 degrees. And again, that we got by going like that. So that's the angle, negative 75 degrees. Since it's a negative angle, we rotate counterclockwise. I'm sorry, clockwise, 75 degrees. Our reference angle is the angle that's made with the terminal side of my angle and the positive x-axis, or in this case, positive x-axis, because if I were to use my terminal side and the negative x-axis, that's going to be an obtuse angle. And I know that my reference angle is always an acute angle, because what we're really doing is referencing an angle in quadrant 1. So the measure of my reference angle, which I will use phi to denote instead of theta, will be 75 degrees. Because if this angle's 285, then to get to my x-axis, I need 75 more degrees. So that's how you graph an angle, that's how you find coterminal angles, and that's how you find a reference angle. So let's do another example. Let's graph negative 830.5 degrees. Let's get my axes. Standard position, so my vertex is at the origin, my initial side's my positive x-axis, but since it is a negative angle, I'm not going to graph this going counterclockwise, I'm going to graph this going negative clockwise. So I have negative 90 degrees, negative 180 degrees, negative 270, negative 360. Now I'm going to have to go around again because I'm not even close to 830. So keep going, and keep going. So that's negative 720 degrees because I've now gone around twice. So this is now negative 810 degrees, and this would be negative 900 degrees. So negative 830 degrees is there. So again, it's really important that we draw the angle of rotation, because otherwise how would I know that this angle is negative 830.5 and it's not just one of its many coterminal angles? So moving clockwise around once to negative 360, around twice to negative 720, and then around a bit more to negative 830.5 degrees. So there's my angle graphed in standard position. Now let's find our coterminal angles. So if I take negative 830.5 and I add 360 to it, I'm still at a negative angle. So that can be one of my negative coterminal angles. Now to find a positive coterminal angle, I'm going to have to add 360 degrees again. But when I add 360 degrees again, I'm still at negative 110.5. So I'm still at a negative coterminal angle. So I could say that my negative coterminal angle is negative 110.5. That would also be a correct answer. So now I'm going to add 360 degrees again, and finally I'm at a positive 249.5 degrees. So I have my negative coterminal angle of negative 470.5 degrees and my positive coterminal angle at 249.5 degrees. And again, there's infinitely many possible correct answers. So I could keep adding 360 degrees to get way more positive coterminal angles, and I could keep subtracting 360 degrees to get way more negative coterminal angles. So now let's find our reference angle. So again, the reference angle is the angle that is made with the terminal side of my angle and the x-axis. So that is going to be my reference angle. So since this angle is at negative 830.5 degrees, and my reference angle will be the angle that gets me up to my x-axis, which is at negative 900 degrees, my reference angle is going to be 69.5 degrees. Because again, it's always the acute angle and it's always positive. So even though I would need another negative rotation of 69.5, I'm still referencing the positive 69.5 degrees, because what I'm technically doing is referencing this angle right here. So the vertical angle. Let's do a couple examples in radians. So yesterday we talked about how a full circle is 2 pi radians, because if the circumference of a circle is 2 pi r, then that means that it takes 2 pi times our radius, or 2 pi radii, to complete a circle. So that means that it takes 2 pi radians to complete a circle if we're talking about the angles. So again, I'm at 0 degrees, or 0, sorry, radians. So if I travel, so it's 0 radians, all the way around my circle, I'm back at 2 pi radians, because a complete circle is 2 pi radians. So half my circle, like we talked about yesterday, is pi radians. A quarter of my circle is half a pi radians, and 3/4 of my circle is 1.5 radians. So if I'm breaking down my circle, and I know I keep saying circle and we're not really looking at a circle, imagine there's a circle here. If I'm breaking down my circle, I would have no degrees, no radians, pi over 2 radians, pi radians, 3 pi over 2, 2 pi. So let's go ahead and let's do another example. Let's do the same directions. So let's graph our angle. Let's find the reference angle and find two terminal angles, but let's use radians. So example 1, let's do 2.79 radians. So if we break out our axes, this is 0 radians, this is pi over 2 radians, right? Which is about 1.72. And this is pi radians, which is about 3.14, etc. So 3 halves radians, that's what 3, 4, about 4.86, etc. So if I'm graphing 2.79 radians, again, standard position, so my origin is my vertex of my angle, terminals, or my initial sides, the x-axis. My angle of rotation will be counterclockwise because it's positive 2.79 radians. So that's about 1.72 radians. So 2.79 radians will be there-ish. So that would be my angle graphed in standard position. So now let's find our coterminal angles. Since we were given an angle in radians, not in terms of pi, let's round our answers here. So to find our coterminal angles, I can find another angle by going around the circle in the positive direction. So taking 2.79 radians plus 2 pi, right, plus a complete rotation. So that ends up being about 9.07. And then I could also find another coterminal angle by making a complete rotation, but in the opposite direction. So that angle would be about negative 3.49 radians. So there's our two coterminal angles. Now let's find our reference angle. So the reference angle is the angle that is made with the terminal side and the x-axis. So if my angle is 2.79 radians, and to get to the x-axis, I need 3.14 radians, my reference angle needs to be 0.352 radians. Because 1.72 plus 0.352 gets me about to, 2.79, my angle, plus 0.352 gets me about to 3.14, so about to pi. And typically we do not round these, but since my initial angle was not given in terms of pi, we will not give these in terms of pi. We'll actually multiply pi in. So now let's do another angle that's in terms of pi. So let's do, for example, 25 pi over 6. All right, so I have 0 radians, I have pi over 2 radians, pi, 3 pi over 2, and then my full circle, 2 pi. Problem is, my denominator is in terms of 1/6. So to make life easier, I want to make all of these in terms of 1/6. So this is actually 3 pi over 6, right? That's 3 pi over 6. This is 6 pi over 6. This is 9 pi over 6, and 2 pi would be 12 pi over 6. But notice, if I make a complete rotation, I'm only at 12 pi over 6, and I want 25 pi over 6's. So I need to make another complete rotation, because now I'm at 24 pi over 6's. So now I just need one more pi over 6. And there's my angle, 25 pi over 6. Because again, I made one complete rotation, which is 12 pi over 6's, another complete rotation, which is 24 pi over 6's, and then I need just one more pi over 6. So my coterminal angles since I have already gone around my angle or my circle more than once, I can subtract 2 pi to get a positive coterminal angle. And if I subtract 2 pi again, I'm still at a positive coterminal angle. So I want to subtract, so subtract 2 pi, I'm at 1 pi over 6, so still a positive coterminal angle. So either one of these answers is A-okay. So I want a negative coterminal angle, so I have to subtract 2 pi again, and we get negative 11 pi over 6. So there are two coterminal angles, one positive, one negative. It doesn't matter which positive one you use because, again, there's infinitely many. So I found pi over 6 as a positive coterminal angle and negative 11 pi over 6 as my negative coterminal angle. So now to find my reference angle, again, it's the angle made with the terminal side of my angle and the x-axis so that it's an acute angle. So since I am 1 pi over 6 past my x-axis, my reference angle is pi over 6. Always positive, always acute. All right, so that concludes our lesson for today. So at this point, please go ahead, get out your in-class note packet and practice graphing angles, finding reference angles, finding coterminal angles. When you are finished, I would like you to go onto your Google Drive to check your answers. While you're working, I would like you to work in your groups of 4 since I'm not really there today to answer any questions. If you finish before the end of the period, you can work on your homework. If not, your homework's your homework. All right, I will see you all on Monday. Have a wonderful weekend.